Good morning. This is our lesson on solving radical equations. It's one of, I think it's a more fun kind of lesson, but my idea of fun is not exactly normal. Uh, um, anyway, what we're going to do is go through the steps, and then I have 5 examples. So it seems like a lot, but I think once we get the hang of it, they actually go fairly quickly. And then we'll take a day tomorrow to just kind of get all of our practice in. So kind of the same structure where we have a shorter lesson followed by an entire day worth of practice. But we'll also look at some calculator stuff tomorrow, maybe. It depends on how things are going. So what I'm going to do, and it's been a while since I've done this, and I messed that up right away, is I'm going to give you a general strategy on the left with a whopping 3 steps. And I'm going to work an example on the right. And that example is going to be the square root of x plus 3 is equal to 7. And what I'll do is I'll color code the steps with my example so that when you're looking at the steps later, you'll be able to match them up. So you'll know what exactly we're talking about when I write like a particular step down. And then it looks like in the hard copy, I actually kept the same color coding through every single example problem. So you get really used to like the different colors there, but we'll see how that goes. So step number 1, actually I'll try to keep the colors consistent here, is to isolate the radical. And let's be really specific. We want to make sure we know what that means, because you can copy down these steps. You could even have access to these steps during a test. But if you don't know what isolate the radical means, it does you absolutely no good to have those steps. So when I talk about the radical, I am talking about whatever the radical is, whether it's a square root, a cube root, a fourth root, a fifth root, and everything underneath it. Not anything multiplying it and not anything adding it. Like, it's the radical itself with the index, because that's part of the radical, and the radicand, whatever's underneath it. To isolate means to get by itself, and we want to be really specific. We mean to isolate on one side of the equal sign. Okay? So I'll say on one side. Okay, so that's what we mean. So in this example over here, I've got the radical x, and it's pretty well isolated except for this plus 3. This plus 3 is not part of the radical. So in order to get rid of that, I'm going to subtract it because it's being added, and because positive 3 plus negative 3 or positive 3 minus 3 is 0. That's what dictates, like, it's been a while since we've solved equations. So that's what dictates what we're going to do, and then I have to do the same thing to both sides. So that gets me the square root of x is equal to 4. And that's what we mean by isolate. I'm going to demonstrate that in like a whole bunch more examples too. Second step, once you get it by itself, is to undo the radical, which is why it's so important to know what the radical symbol means, what the index means, because that's how you're going to determine how you undo it. So I don't typically copy that over again. I just want to copy it again to clean the work up. But this is a square root. And how do you undo a square root? With squaring. And if you square one side of the equation, you have to go square the other side in order to keep it equal. And then I guess we'll do the last step in red. The last step in red is solve the resulting equation. And we call it a day. So when I square the left, I get x, and when I square the right, I get 16. And in this particular problem, there is nothing left. Now, we keep them fairly simple in Algebra 2. Radical equations do get horrible. There are different variations on these that get really, really bad, and that you end up having to like square everything twice, and then you have like a quadratic at the end, and they're really, really long. If you were taking Algebra 2 at the honors level, you would tackle every variation on radical functions there are. And when I teach college algebra, we go through all of the really ugly versions. For most of you, this is the first time you're encountering radical equations. And for a lot of you, you're not going to go into pre-calculus, calculus, or college algebra. And so we don't need to go that far in depth. But I do want to be really honest. If you're thinking about going to pre-cal, this is one of those areas where you'll be a little bit uneven from your honors peers, because they do move faster and they do up the level of difficulty. So this is just one of those areas where it's apparent. Okay, so let's go through the examples. Here's our first one. It is the cube root of 2w is equal to 4. And I'll just kind of keep coming back to this slide, which is how you would use your notes. You keep coming back. Okay, step 1, isolate the radical. So I kind of look at this, and I got the radical, the index, and the radicand, and I don't seem to have anything else. And so I'm going to do step 1 is already done. There's just nothing left for me to do with that. And I'm going to see if I can get rid of this circle because it's kind of in the way. There we go. Step 2 is to undo the radical. Well, in this example, and I'm going to recopy this, and I won't typically do that, just so you know. This particular example, this is a cube root, and because we studied and listened to Miss Taylor when she taught us about cube roots, we know that cube roots are undone by cubing, because that was what a cube root was. So if I've got a cube root and I want to get rid of the cube root, I can cube it. And that is going to leave me with 2w, and then 4 to the third power is 64. Hopefully that is... cube both sides. I'm just making a couple annotations over here. You're starting to recognize the 64. And then step 3 is solve whatever the equation is. And in this case, we actually do have some steps there. We have 2 times w, so we actually do need to divide both sides by 2. And we get w is equal to 32. And that time you got to see 2 of the other steps. We didn't have the first step. All right, example 2. Moving on. And this one is 2 plus the square root of 3p plus 7 is equal to 6. So step number 1 is to isolate. And so I am going to just circle, there's what I want to isolate. I want to isolate the radical, the index, and whatever's underneath it. So that's what I need to get rid of. We need to get by itself. I need to get rid of the 2. Now, just be careful here. This is a positive 2. That sign on the 2 is what dictates what you're going to do, not the plus sign here. Okay, I want to be really clear about that. Even if that were a minus sign, you would still have to subtract the 2. It's the fact that it's a positive 2. So I'm going to subtract 2 from both sides, and that's going to give me the square root of 3p plus 7 is equal to 4. Now we undo the radical. This is a square root, so I will undo it by squaring. Now notice that I didn't bother recopying that time. I just kind of squared it on the existing line. Like the other ones, I recopied it so that the undoing was in a different spot. But usually I'll just undo it like right on that step. And I'll switch the color up. When we square a square root, we undo it and we get whatever was inside. Notice that you don't mess around with the radicand. So you're not squaring the 3 or the p or the 7. Like the squaring is how you're getting rid of the square root symbol, but it doesn't touch anything on the inside. So that's a common mistake for students who don't do any practice problems, and then they get to the test and they're like, what is this? And they start messing around with the radicand. So if you're going to do that, get it out of your system early on so you can fix it. And then the last step is to solve whatever equation is left. So in this case, we'll subtract 7 from both sides, which will give us 3p equals 9, and then divide both sides by 3 to get... What was that? P equals 3. Sorry, I didn't, okay. I didn't space it, and then I've timed it out. I'm doing weird stuff. Like you guys can't see it, and so I probably sound like I'm losing it a little bit, but like, trust me, there's weird stuff happening on my iPad. Okay, that was example 2. Moving on to example 3. Each of the examples, by the way, does show something slightly different, whether it's an expression under like the radical, or whether it's a different kind of radical. This one is the first one where we're dealing with something multiplying the radicals. So each example really does have like a slightly different twist to it. So you just be alert for that. I'm not trying to waste your time. All right, step number 1 is to isolate. And so remember what I said when you're looking for what to isolate. You're looking at the radical, the index, and whatever's underneath it. So in this case, it does not include the 3. We cannot have the 3 there. Now, there are some problems that I do in college algebra where we actually will keep the coefficient there, because getting rid of it means we end up with a fraction, and we try to avoid the fraction for as long as we can. But not in this case. So this, remember, is multiplication, and that's why I try to drive that home. And so we undo multiplication with division. So I will divide both sides. 3 divided by 3 is 1, which is why they cancel out. Always know why they cancel out. And 9 divided by 3 is 3. So now I have the 4th root of 2x is equal to 3. Step number 2. Undo the radical. Now, notice that I'm getting like this over here is becoming briefer and briefer and briefer, okay? So I'm not writing out the whole step. I'm just trying to write out just enough, like one word that's going to prompt you to remember what we're doing. And ideally, you do enough problems and you look at it enough that you stop needing this at all. We'll see if I can keep scaling it back. This is a 4th root, and so you draw on your knowledge of what a 4th root is, and you like, okay, I undo a 4th root by raising to the 4th power. Whatever you do to one side, you have to do to the other side. If you take the 4th power of a 4th root, you will get whatever's inside. Again, don't do 2 to the 4th power. Like, that's not what the 4th thing is doing. You're just using it to get rid of the radical. 3 to the 4th power is equal to 81. And then our last step is to solve whatever is left. So that is multiplication. And you can leave your answer as an improper fraction. That is totally fine. Or, I don't know why I changed it over to 40.5, but that's the decimal equivalent. Usually math people like it as the fraction better. And then like scientists and engineers will go for the decimal a little bit more. All right. Oh, this is so much fun. Just kind of cruising on through. Remember that this video is posted on YouTube, so you can go back and look at the whole presentation again if you feel like I've gone through something a little bit too fast, and you just need to hear the explanation, or I took it off the screen a little bit early, and yeah. So this next one, this one is, oh, what, hang on, what, okay, I don't know what happened. I don't know how I moved that up. Like, I don't know how I did that. That was really weird. All right, this next one is the square root of g plus 1 equals the square root of 2g minus 7. And so for a moment you panic and you're like, hold up, you can have more than one square root? Yes, you can. These are the ones that actually get really ugly, where you end up squaring a really nasty binomial radical expression, like one that's way worse than just numbers. You're going to have like, I don't know, 2g minus 7 in the middle of it, but we're not going to go that far with it. So I like this problem because it does test, the strategy that I gave you. And so step number 1 would be to isolate. And this is where the ones that are really ugly, like where they get ugly because it turns out you can't isolate both. Now in this one, they actually are both isolated. So you have one radical by itself on one side and another radical by itself on the other side. Maybe if there's a lot of time left in this video, at the end, I'll just show you what the other ones look like. And we'll discuss some strategies for how you can get multiple choice questions right on the other kind, should you see them. So this one is already isolated. So now we're going to undo. And fortunately, they are both square roots, and so I can undo both of them by squaring. If you have mismatched roots, so if you had a square root and a cube root, one, you could cry for a moment, and two, you would have to change them over to exponents and see if you could tackle it that way. But I've never seen ones with mismatched roots in it, or at least I've seen them so rarely that I don't remember seeing them. So don't worry about like, oh, I'm going to take the EOC or I'm going to take the PERT and they're going to give me something with mismatched radicals. I highly doubt it. All right, so on the left-hand side, if you square a square root, you get what's inside. And on the right-hand side, if you square a square root, you get what's inside. You Try to avoid saying stuff like the radicals disappeared. Okay, they didn't vanish. We operated them out of the problem by squaring both sides. So we were able to get rid of the radicals, but they did not just vanish. Now we need to solve the equation. And for whatever reason, sometimes for some of you, like the moment you see the variable on both sides, like the wheels fall off. Just everything you learned about equations, like none of it has changed. So if I have a g on one side and two g's on the other side, I am just going to take away 1g. Take away, like back to first grade arithmetic. You have adding and you have takeaways. If you have a g and you take away a g, like you are left with, oh, I meant to do that in red. I'm trying to be consistent here. With the 1, if you have 2 g's and you take away 1g, you are left with 1g. And then you add the 7 to both sides, and you get 8 is equal to g, and you're good. You could also do that like the other way. So if somebody, I mean, I don't know why you would, but some people do. Some people like to get the variable on the left-hand side. And so they'll do minus 2g, which will give them negative 1g. And then you have like the negative 7 over here, and then you'll subtract 1. So you'll get negative 1g. Sorry about that. I did it in my head. That should show me right. There we go. You get negative 8 and then divide by negative 1 and you get the same answer. This is a disadvantage because there's negatives floating all over the place. So if you've got a way that you can do it without the negatives and then you have a way to do it with the negatives, like go without the negatives. Like don't volunteer for extra negatives. All right, last one. I told you we had 5 examples. We are cruising. All right, and so this one is 4x minus 1 to the 1/5, and then another minus 1. Oh, this is great, equals 2. And you think, Miss Taylor, you titled this lesson Radical Equations, and that's not a radical equation, except that it is, because in the last lesson, we learned all about rational exponents. And so this is really the 5th root of 4x minus 1 to the first power. We do not need to write to the first power, and so we can just like leave that part off. But you want to kind of remember that it's there. It would get pretty ugly if you had something other than a 1. And so it really is a radical equation, and that entails that you remember like what your rational exponents are. And now our strategy defaults back to the same thing. So you isolate. Here's the radical right there. So I need to isolate it by getting rid of that 1. And then that will give me the 5th root of 4x minus 1. Negative 1 plus 1, of course, is 0, and 2 plus 1 is 3. Step 2, undo. This is a 5th root, so we undo it by raising both sides to the 5th power, which will give us 4x minus 1. And then you probably need to bust out a calculator for this, because most of us don't know 3 to the 5th power off the top of our head, but we could calculate it. It is 243. And then the last step is to solve. So we'll add 1 and we get 4x equals 244. This you can actually divide in your head, because you could think to yourself, okay, how many times does 4 go into 24? And it's 6. And then how many times does 4 go into 1? Or 4 go into 4, which is 1. Or you can take out your calculator and divide it out, but we end up with x is equal to 61. So there's your five problems. We'll just kind of go back and recap, because that's why I have this program. So there's your general strategy. Isolate the radical. You do have to do that first. Then undo the radical. When you undo the radical, make sure you do not mess with anything in the radicand, okay? The undoing the radical is just to get rid of the radical, and it doesn't touch the radicand. And then solve the resulting equation, whatever that might be. In higher, more advanced versions of these problems, the resulting equation could be a quadratic. It wouldn't necessarily be a linear one. So just be aware that the difficulty level does ramp up. Then we had the first example. Second example introduced a radical other than a square root and an equation to solve at the end. This one introduced an expression underneath the radical, as well as what to do with the leading number. This one introduced multiplying by a number, so you have a number multiplying the radical, and also had the equation and the answer was not an integer. This problem introduced the idea of two different radicals. So what do you do if you have more than one radical? And we also reviewed how to solve a linear equation with the variable on both sides. And then the last one kicked it back over to our rational exponents, that you might see equations that have that in them. So each of those examples kind of layers on a slightly different aspect of it. And if you can understand each one individually, then bravo. Here is an example of one that gets yuckier. This isn't even as yucky as it could get, but you run into a problem right at the beginning, because the first step is to isolate, and you can't isolate them. You have a +1 over here and be like, oh, I want to isolate that. So you would subtract 1, but all that would do is like bring it over to the other side, and now this one's not isolated. And so like you really kind of trip over the strategy right at the get-go where you can't isolate it. So you have to jump to the undoing. And so because it's a square root, you're going to undo it by squaring both sides. The left-hand side is actually pretty nice. That's just a 2x. It's the right-hand side that is going to make you glad that Miss Taylor is not going to ask you to do it. Because that is a FOIL problem where you've got to distribute like through with all of the like the square roots in there, and that ends up being like x plus 1 plus, I'm foiling it without showing the steps. And then you notice that there's still a square root in it. So I'm going to subtract x from both sides, and then I'm going to do 1 plus 1 and get 2. So I'm going to have 2 plus 2, and then that's just an x, and then we subtract 2, and I think you get the feel of like, oh, crud. And then we'd have to kind of start the process over again. But now I have one radical, so now you can isolate it. This is one of those where I actually I would keep it over there to square it, because otherwise you're going to have a fraction with the denominator too. But I kind of want you to see that just so you can see how wonderful these problems can get. And I don't want to hear anybody complaining about how the problems are too hard. Because I can send you to another Algebra 2 class where you can enjoy that. Now, here's the good news. If you do have a problem like this, and you encounter it on the PERT test or on like your EOC or on, I don't know, whatever else you might be doing, is that probably it is going to be multiple choice. And what you can do is you can take whatever the number is, and you can plug it into the equation and see if it makes the equation true. If it makes the equation true, then you know you have your answer. If it does not make the equation true, then you don't. So you still have some tools at your disposal for for getting the answer to these, even if you haven't been taught all the explicit algebra steps. Incidentally, the way that I did that, there's nothing in there I haven't taught you. It's just really ugly and messy, but it's all stuff that you've been taught how to do, from like multiplying square roots, foiling, combining like terms. There's nothing in there that's new. It's just really messy, and it's giving me a headache just thinking about it. So we'll wrap up the video there, and next class will be strictly practice.